Jada received a gift of $180 in the first week. She spent a third of the gift money. She continues spending a third of what is left each week thereafter. Which equation best represents the amount of gift money in dollars she has after T weeks? So raise your hand if you said number one best represents it. Raise your hand if you said number two best represents it. Raise your hand if you said number three best represents it. And raise your hand if you said number four best represents it. Okay, so I didn't see any hands for number one. Why is number one definitely not it? Because there's no parentheses. Technically, okay, so let me ask you a different question. What setup is number one in? That matches what type of function, the way that number one is set up. Harley? Good. Number one is in the same setup as our linear functions, the y equals mx plus b. And this is definitely not a linear function. So those of you that maybe didn't have an answer, I'm trying to help you like problem solve your way through it. This is something you all should have gotten. Maybe one minor thing is tricky, but you all should have definitely looked at number one and said, oh yeah, that's linear. That's definitely not what's going on. Because in this problem, what is going on is that it should represent what type of function. It's not linear. The only other type of function we've been talking about is exponential. And exponential functions are always in what setup? Just like how you know linear is y equals mx plus b, you know that exponential is okay, good. Or some variation of this. There's a few variations we've done, like where b is the 1 plus or minus the growth rate and stuff, but a variation of one of these two. And that's why we said, oh, there's no parentheses. Technically, I could write it without parentheses and it's still exponential, but I knew what he was talking about. Like, he meant it's not set up in an exponential way. So that's why it's not one, for sure. The rest are set up in an exponential way, but only one of them is correct. Not many people chose number three. So why is number three incorrect? So we'll refer back to the equation. Because 180 is my initial amount. Let me move this if it'll let me. Oh, no, not in an easy way. I'll erase this for now. But we know that in our exponential functions, a is supposed to be our initial amount. When you read the problem, 180 is our initial amount. That means it should not be attached to an exponent. Your initial amount should never be attached to the exponent. Like I could choose to write them in a different order, but your initial amount should not be what you're timesing by each time. Okay, so between 2 and 3, which I think for this class was pretty like evenly split. So 2 and 4, I think I said 3, but I meant 2 and 4. Both have the same initial amount, which is correct. It's this part that's different. In one of our lessons, I want to say it was like a week ago, we talked about how when it's decreasing over time, you multiply by what it's keeping or by what it's losing. Incorrect. You don't multiply by what it's losing. You multiply by what it's keeping. Okay, so let's do that. So if you get stuck, maybe make a table. So X would be time. We're talking about a time frame of weeks. Week 0 would be your initial amount, which we said is 180. If she is spending a third of what she has, what's a third of 180? $60, right? If you split 180 into 3, 60. But that's what she's spending. So how much does she have after 1 week? Like, lose you at some point, like, everyone pay attention, I'll repeat it. What's 1/3 of 180? And if she's spending a third of it, she's spending $60 of it, how much does she have after 1 week? Okay. Then she's spending a third of what's left. What's a third of 120? 40. If she spends 40 of that, how much does she have after the next week? 80. Now, timesing by 1/3 doesn't get me that. Okay, because the B is supposed to be what you're timesing by, and I'll show you. If this is supposed to be my equation that represents it, I should be able to plug in the T value and get what we are reasonably coming up with. So when I plug it in, and you all will need technology today, don't be stubborn or else you're just gonna get embarrassed when you're called on. But 180 times 1/3 to the first power, because to the zero power, it should give you the same amount. But to the first power, it tells me that I should have 60 after 1 week, when I know that it's actually 120 that she has. She was spending 60. So that's why if you change this to 2/3, now it's giving us the number we want. That we already figured out is what she would have like week after week. If I change that to a power of 2, that's matching my table. So that's why the answer for the warm-up should be 4. Because you have to multiply by what is remaining. So multiply by what is remaining, not what is losing. Soon as it says she's spending a third, or in other words, losing a third, you need to do basically 1 minus what they're losing. What's 1 minus 1/3? Then you don't have to give me the decimal, just if I have a whole and I take away a third, how much do I have left? 2/3. All right, that's why we also have that other variation of this equation, where B could be 1 plus or minus, depending on what's going on. Because the R would be like the rate it's decreasing by. And B is what you're multiplying by, so it just depends. Always multiply by what you're doing. So questions on that? All right, really good warm up, because number 2 is a really common mistake that people make. You gotta multiply by what's remaining. When in doubt, make a table. Now. So follow along with the learning targets on your paper. While I pull it back up. Today we are really looking at how changing A and B changes the equation. So like without necessarily graphing it, you can predict things about whether it's growth or decay from looking at the equation. So by the end of it, you should be able to describe the effect of changing on a graph that is represented by an exponential function and use equations and graphs to compare exponential function. I'm recording right now. It'll be linked in the slides. Puzzle piece is lesson 12. And your quiz isn't until next week on Thursday. Now, Okay, sub yesterday left a note about this class, and it's not like the worst note I've gotten about this class.
Hey, I was really stressed, so I didn't contribute.
Okay. It wasn't the worst note. I know that this class tends to be more chatty than some of my other classes. It's probably my biggest class. Although my period one is also just as big and they got a beautiful note, right? But like I come to expect that you guys tend to be more chatty and stuff. But when the sub has to single out by name, because I told you before, I leave your pictures so that they can identify you by name. But identifies people that didn't do anything. It's just so annoying to me because then it's those people that are constantly like on my case when they turn in their missing work, they want it graded that second. It's just super annoying to me. Like, what about you do the work when I assign it to you? Do you do the work 10 seconds after I assign it to you? No? Then don't message me 10 seconds after you turn it in to update your grade. Same with like my math lab kids, which I have a big chunk in here that I also have to math lab. I told the sub in the instructions yesterday, like, tell me a list of all the people that are using it as free time. So I can go back and check, did they do all the things on this list? No, they didn't. So for those kids, I'm going to make them turn in their phone and headphones to me every day until you get your stuff turned in. Like, that's not okay. Like, don't waste my time. Because you can't do anything during the while the sub is here. Okay? Now I wanted that on the recording because I do have to leave after third hour, so my later classes will also watch this recording, at least they're supposed to. But regardless, like I'm not going over the lesson again. It's all on video. It's on video since last year. So I mean, it's your problem if you fail and have to take the class again. Entirely your problem. All right, but moving forward, less of the negative. Now onto meeting our learning target. So equations and their graphs. Each of the following functions, F, G, H, and J, represent the amount of money in a bank account in dollars as a function of time X in years. They are each written in this format, which when it looks like this format, what type of function is it? Incorrect. What formula is linear functions? That's,
Oh, probably.
yeah, what equation are linear functions actually in?
Why doing this complete?
So this is not linear. Okay, it's a times b to the x, which is what type of function, class? Exponential, good. So you should be able to tell me in each situation what the a represents, what the b represents, but not right now. Right now, what we're gonna do is graph each of these, compare it to the graph that's on your paper, and identify, oh, the yellow line is f of x, the blue line is g of x. Not necessarily saying that's true, because be able to use your graphing technology to identify the correct line. Those should be really easy problems on the test. When it says which graph matches this function, you all get Desmos on the test. Maybe not on your state test, but on any other test you do. So I should see everyone practicing it. And if when you're called on and you don't have an answer, we can wait for you to put it in the Chromebook or in your other graphing calculator or whatever. But everyone needs to practice using it. It might look a little weird when you first put it in, so that's why a few lessons ago I showed you how to adjust the window with Desmos. If you can remember yourself how to do it. But otherwise, that's your first class. Then compare how the B changes the graph. We change the value of B, how does the graph change? So first, let's just see if anyone can figure it out. I know the window looks ugly when you first look at it, but I have previously shown you how to fix it so you can better identify them. So yeah, I'm good. Yeah, thank you. Okay. Okay, anyway, yeah, I'll show you to fix the window, but just using your critical thinking skills, I'm gonna rotate between the tables. You're gonna tell me one of the ones you matched. So, and I won't tell you if you're right or wrong yet. So table 9, can you tell me one of the matches you made? Okay, J of X goes with the yellow one. Since you guys have the equations up here, you could just put J of X as like the label. Table 1, tell me another match that you made. Okay. One of them has already been taken. What is one other match you made? Table 2, tell me another match that you made. That's the left to the red one. So then process of elimination, we'll say that the green one's H of X, but we're gonna confirm right now. Because I know the window is ugly, but let's just see if anyone figured out how to make it look better. So Desmos is super user friendly, but of course you don't get it on your state testing. So consider getting a real calculator and learning how to use it. YouTube's very helpful. But you could even type in the function notation into Desmos. So that's what you probably should have done first so that you can better compare them. I think the only hard part, I think, is knowing how to put the exponent in. There's a little button right here that lets you put in whatever exponent you want. But okay, so notice that if I were just to look at Desmos, it shows me all the quadrants, but on the graph that's on your paper, it only shows me the first quadrant, like where all the numbers are mostly positive. So in that case, what you'll probably want to do, and I think this one was already adjusted, so that actually kind of doesn't help me show you, but this one was already adjusted. Yours probably looks way ugly, but the way that you make it look better is by changing these values. So if you click on the wrench and you go to the x-axis, see what your x-axis was on your paper. So it went from like -1 to about 5. So you could change your x-axis to fit that. -1 to about 5. So that it's showing you the same thing that's on your paper. For the y-axis, it goes from 0 to like above the 200. So then I'll change my y-axis values to like 0 to above the 200, maybe like 250. And now it's easier to truly see which is which. Now it matches what's on my paper. So did we get any of them wrong? Granted, the colors are different. But J of X is definitely the one that goes downward. H of X is the one that I guess goes more to the right out of the 3 that are going up. F of X is in the middle. And G of X is that steeper one. So good, our matches are right. Questions on that? Okay, so notice what was the same about each of these equations? They all had 50s for the A. So that's why when we looked at the graph, they all came from the same y-intercept. So this example is good because all that's different is the B. You can really see how the value of B changes the graph. All right. Can we like generalize that at all? Did anyone come up with a good generalization about the value of B? So you see how G of X, F of X, and H of X all go up from left to right? What do we call that? Growth or decay?
True.
So F of X, G of X, and H of X are all growing. Look at those B values. For F of X, what's my B value? 2. For G of X, what's my B value? I should hear more than one person. B is always what's attached to the exponent, right? So then in H of X, what's my B value? 3/2. If it's hard for you to compare fractions to other numbers, make that a decimal. What's the decimal version of 3/2? 3 divided by 2 is 1.5. And now compare that to J of X, which was the only one that was decaying, decreasing from left to right. Look at that value of B. What's the value of B for J of X? So what generalization can you make? When is it growing? When B is what? A whole number? Well, 1.5 is technically not a whole number, but it's still growing on that one. So how can we generalize that? Whenever B is this, it's gonna be growth. Greater than 1, good. So whenever B is greater than 1 in your exponential functions, the function is growing. So maybe write that down as the main point. This would be like when it's doubling. It would be like when it's tripling. This is going up by, you could say 150% if you want, or just timesing 1.5 each time would make it bigger. Anytime you multiply by a number bigger than 1, even if it's just 1.01, it's gonna make that number bigger. So then, on the flip side, whenever B is what, it's gonna be. So whenever B is less than 1, it is decay. And that, if you go back and look at all your notes, all the problems, is true. Anytime that we were losing something, that B ended up being smaller than 1. All right, that's why when we talk about the 2 variations of our exponential function, this one and the one where B is replaced with this, depending on whether it's growing or decaying, that also like re-explains this. Because R would be the rate that it's growing by. So if it was growing by 50%, you would make it a decimal, add it together, you get 1.5 for the B. That's growing. Whenever we said it was decreasing by, we could say 50%. That's when we made it the minus, and that ended up making our B smaller than 1. Okay, so remember that. That's how you can kind of know without necessarily having to graph. Questions on that? Now, also look at, because these 3 are all growing, so kind of compare them. Which one's growing the fastest? G of X. And how do you know visually? Stuff that grows faster is always okay. Can you tell me which of these 3 are growing the slowest? H of X is growing the slowest. So like steepness kind of affects like how fast it's growing. So the steeper graphs are growing at a faster rate. But also if you look back at the equation, doesn't that make sense? For g of x, the b was 3. Isn't tripling growing faster than like doubling? And isn't doubling growing faster than timesing by 1.5? So you can see that visually as well. So you could also say, and it just kind of depends whether it's growth or decay. But like, you could also generalize when it is growth. A greater value for B grows fastest. Not necessarily true for the decay, so that's why I said when it's growth. We only have one example of decay on this one, so we'll have to see in the later one. But when in doubt, maybe just graph it. And you can see which one is growing fastest, which one's growing the slowest. Questions on this one? So you're gonna do something really similar with number 2 on that page, where it's now changing the A's. Also, there's a typo, so I need you to fix something on that one. So for number 2, P of x should be 10 times 4 to the x. On your paper, it says 100, and it's not. So fix this, I highlighted it. It should be different from R of x. So in number 2, you're going to observe how changing the A value changes the graph. And you're going to label each line to correspond with what equation it should go with. So do that, use your graphing technology to confirm. I'd say 2 minutes, no more than that, I think would be good. So Ron, tell me which color line goes with P of x. Red? Wait, what orange one? It's red, blue, or black. Okay, so you're saying the red one goes with P of x. Let's see, table 4, sorry, I know it's just you, I should have caught that earlier, but which one goes with Q of x? Okay. The middle one. And then table 5, which one goes with R of x? The red one, okay, so it looks like.
There's a typo.
Yeah, I know, I told you guys to fix it.
Oh.
That's why we gotta listen all the time. But if that was what made it incorrect for you, then that's fine, because it should go in this order. Yes,
The last one, I like the black one.
is for P of x.
Yeah.
Okay, thank you. All right, but yeah, so remember I told you guys to change it to this. There was a typo on your paper. But using this setup, this is appropriately matched. Now, I know that without having a graph because of what detail on the graph. So look at all my equations. What's the only thing that's different? Other than like the letter for the function. The A value. What does the A value correspond to on a graph? And what do we call it on a graph? Starting value on a graph is usually your y. So A corresponds to the y-intercept. That's a generalization you can make that could help you figure out which is which without even having to graph it. So like R of x, which has an A value of 100, has a y-intercept of 100. Q of x, which has an A value of 40, has a y-intercept of 40. And P of x, which has an A value of 10, has a y-intercept of 10. So imagine that. A corresponds to the y-intercept. Otherwise, like all of these had the same B value, so they should have been both increasing at the same rate. They just start at different places. So that's what it corresponds to. So I guess you could say the higher the A value, the higher the y-intercept is. That's like the only real difference on the graph. Now, on your test, they did try to like throw you off with one of the options having a negative A in it. So I'm going to show you what a negative A would do, even though that wasn't one of the ones you had to look at. So say that I graph one of these, like 10 to the 4, or 10 times 4 to the x power. Okay, so take a good look what it looks like. Now look at what happens when I make the A value negative. Okay, I'm going to change it back so you can look at it again. Because we know that when the B value is greater than 1, which this one is, we know that it's growing. But when I change the A value to negative, it no longer looks like it's growing. It's actually decaying. So just pay attention to that too. Don't automatically assume, like maybe confirm with your graph as well. They will try to trick you like that. They'll give you something like this, say, is it growing or decaying? Well, since that A is now negative, my starting value is now negative, it's now decaying. It flips over the x-axis. So think about it. If I did -10, which is my starting value, times 4 to the first power, it's -40. If I do -10 times 4 to the second power, it's -160. Are these numbers getting bigger or smaller as time goes on?
Smaller.
Smaller. So this one's technically decay, but only because the A is now negative. If I have to times by 4 each time and my starting value is a negative times a positive is always a negative. So maybe just make a little note about that. A negative A, which is what this is, it flips the function. Really, I should say reflects. That's a more proper word. It reflects over the x-axis. All right, so, and if you forget that fact, just play around with it in your calculator. Make it negative, see what happens. But I just saw that on your test. Usually I don't have to mention that, but since I saw it on your test, I wanted to. Questions on that? Okay. The backside will be like your check for understanding. So you have another situation. So suppose you're presented with 4 functions, M, N, P, and Q, that describe the amount of money you have in your bank account. And assuming like you want more money instead of less money, you're going to decide which of those you would choose. Try to do it without graphing, but you could always graph to confirm. The next thing you would do is match each equation to one of these lines. And then there's one more small part. It's actually pretty fast. You're given 2 functions. You're going to say which one is decaying more quickly. So this is going to check that you understood the lesson today. So I really want you to attempt it, even if you have to guess by the end of it. We'll go over it in, I'd say, 5 minutes. So if you finish early, start your practice, but have this attempted so that you can see, do I need to come to extra tutoring? Do I need to ask Miss Medina more questions? Give it a real shot right now. So ideally, I'm assuming you'd want more money in your bank account. So which one would give you the most money in your bank account? M, P, N, or Q? Raise your hand if you think M. Raise your hand if you think P. Raise your hand if you think N. And raise your hand if you think cubed. Okay, so those of you that raised your hand, did you graph it? Could you tell just by looking at it? Both ways should have gotten you the right answer. Just by looking at it, and this is our first like one that had multiple decay examples. Remember that you were supposed to multiply by what it is keeping or losing. Keeping. So this account is keeping more of the money in it than the others. If it's hard for you to compare fractions, especially with different denominators, convert them all to decimals. 1 divided by 4 is 0.25. 3/4 is what as a decimal? 3/4 is what as a decimal? 0.77. Good. Or 3 divided by 4 in your calculator if you don't know that. 1/2 is what as a decimal? 0.5, good. It is like 0.50, yes. And then 7/8 is what as a decimal? So if you really compare the B values, the ones for decay purposes that are closer to 0 decay the fastest. So in regards to decay, B values closer to 0 decay the fastest. Right, because they're keeping less of their amount. Whereas this one's keeping more of the amount. Make sense? That's how you can tell without graphing. Like on your state test, if you don't have that or a graphing calculator. Otherwise, graph it, see which one gives you the higher amount of money. So if it's higher on the y-axis. So then, class, simmer down. So like a few more problems to go through. No one's leaving until we get through them. So Q of X goes with which line then, if it has the most money in the account? Okay. B goes with which one then? E of X. Because it has the second highest B value, it should have the second most in the account. They all have the same starting value, so we're really comparing like apples to apples. And C should go with which one, M or N? N. I wrote that wrong, only parentheses around the X. And then by process of elimination, this one should be M, and it also is the one that we said decays the fastest. Lower faster. Okay, we have one more to go through, so if you're still writing, write quicker, but that's the matches you should have made. The very last one says between those two equations, don't jot it until I ask you. But between these two, which one's decaying more quickly? So raise your hand if you think that when the B is 1/10, it decays faster. Raise your hand if you think when the B is 9/10, it decays faster. Okay, that's after that. Because it's keeping less. It's timesing by a smaller B. B values closer to 0, decays faster. Make sense? So lots of things you could say. The only thing that's different is the B. Decaying more quickly is the first one. And the one that has more money is B. So your practice is really short. Make sure you do it. If you're in one of my math lab folks, you guys, a lot of you have so much missing assignments. I shouldn't get another note about you still not doing nothing. Should not. Or you'll start turning in your phone to me every hour that I have.